Bismillahirrahmanirrahim. So today we are coming back to paper 1. This is March 2023 for the IGCSE 0620 chemistry. Paper 2 actually, the extended multiple choice. Right. So here we go. So substance M is a solid at 30 degrees. The substance is heated. Would it be okay if I zoom in a bit more? Guess it will work. So the substance is heated to 80 degrees and its temperature measured as it cools, right? So obviously what we want to do when you're answering papers, right, underline keywords. So it's heated to 80 and then it as it cools down. This is a cooling curve. And so whatever changes of states we've learned, they're going to be opposite. So it's noted as it cools to room temperature. The cooling curve is shown. Between which times is substance M freezing?
Option C.
It's either C or D.
Okay, C is between R to S, where you can clearly see a fall in temperature. Freezing
Yeah,
is a change of state. And what's one thing that does not happen during a change of state?
change in temperature.
Exactly, temperature does not change.
So it's D. Yeah.
No. Oh, wait. It's M is freezing.
So it is it D?
Have I got the correct mark scheme? This is for March 2023, paper 22. The suggested answer is B. B is Q to R. So this point.
Do you think that's the correct answer?
Huh?
You think that's the correct answer?
It should be given that they mentioned that substance is solid at 30 degrees, right? So at 30 degrees, it's already a solid, right? It's already in solid form again, right? Notice that mentioning that it is a solid at 30 degrees does not mean that 30 degrees is its melting point, right?
And
I could very well tell you that ice is solid at -4. That does not mean -4 is its melting point. Its melting point is 0,
yeah.
right? So saying that M is a solid 30 does not mean that 30 degrees is the melting point. They've also not given any other detail in that regard. They only said it's a solid at 30, it's heated to 80, and then it's allowed to cool, right? So it's cooling way down till 40, right? And then you see the change of state, and then you say it's cooling further. Now, whatever this is, right, it is not our concern, right?
So it's talking about the at when does the transition happen?
Exactly. When does the transition from a liquid to a solid happen, right? And because they mentioned that it's already a solid at 30, you see the dotted line that I've drawn. So at this point, where you can see that the temperature is further falling, means it's already solid. And so the only logical answer is between QR, which is B.
Yeah.
Karan, does that make sense?
Yeah,
Yes?
yeah, but like, wouldn't PQ be the answer as well?
peak, see again, change of state, freezing is a change of state. The temperature should not change. Between PQ, the temperature is falling. So it can't be
Yes.
PQ, right? When a change of state is happening, the temperature remains constant. Now, once it's already a solid, why is the temperature constant? ST, right? Again, it's not a concern. But, right, or, right, to reason it, since it's given, right, you're like, oh, it's, there must be a reason. It stopped cooling further. Simple. Right? Maybe 20 degrees is room temperature, and so it has achieved room temperature. So we can reason that it has achieved room temperature, right? And so it's not cooling further. So that could be a reason, right? Just because the temperature is stable in this case does not mean that there's a change of state happening beyond uh, solid. Make sense?
Yes.
Okay, just a sec. All right. Okay, next. Which gas has the fastest rate of diffusion? So they've given you these options, they have not told you anything else, right? So what would determine, what are the factors that determine the rate of diffusion?
Uh, the lightest molar mass.
Yes, the mass, or what else?
Higher kinetic speed.
Temperature,
Yeah.
right? So obviously temperature is not given, we can't figure it out. So what's left is mass, right? So we know, right, HCl will be like 35 and 36 approximately, right? This is 24 and 6, so that's 30, right? And then let's take a look at sulfur and argon. So we move to the periodic table, which is given. So argon is 40 and sulfur is 32,
Okay.
right? So 32 and 2, that's 34, and this guy is 40. So which one will have the fastest rate of diffusion?
B.
B?
B.
Yes. Right, so one thing that students might confuse over here is, oh, it's got more atoms, and so it's a bigger molecule, and so it will be slow. That is not a factor that affects the rate of diffusion, right? Although given all of these, this is the biggest molecule you have. Okay, there are two stable isotopes of bromine. One has a mass of 79, the other has a mass of 81. Which statement is correct?
Mhm. I should the C.
They have different numbers of protons? Seriously?
No, 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 no. Wait.
Option D.
Yes, Sobia?
Not option D. Option B.
D over here. They have different chemical properties.
Yeah. Or maybe D.
Or maybe D.
Different number of neutrons.
Okay, so isotopes have different neutrons, right? That's the whole thing about isotopes. And so this is
Yeah.
wrong. Chemical properties are the same because it depends on the chemical properties depend on the element. So if it's an isotope of that element, the chemical property will be the same. And the chemical
They have
properties.
similar chemical properties because their outer electrons are
Exactly,
the same number.
exactly, right? And so they have the same number of outer electrons. That's it. And it can't be different protons, because different proton will mean a different element, right? And so that won't be an
Yeah.
isotope. So this is wrong as well, right? So it's D. All right. Which statement about ions and ionic bonding is correct?
Mhm. Let me.
This is ridiculously straightforward.
A or B?
Oh, come on.
B.
No,
A.
A, only A, right? It gains an electron, right? And it becomes Br minus, right? Ionic bonds, no, these are like Cl2 or Br2, these are covalent bonds. You represent it like this, right? You do not lose protons at all. And potassium ions, like potassium ion have negative charge. Potassium is a metal, and metals always form positive ions. Oh, crossword. Well, periodic table actually. Okay.
Hmm.
Part of the periodic table is shown. Which type of chemical bonding is present in the oxide of F and in the oxide of G?
Mhm.
F is in group 2 and G is in group 7.
Right, so you can label this. This is group 2, which means it's a metal, right? And this is group 3, 4, 5, 6 actually, right? Which means it's like oxygen.
So F would be a covalent bond.
F would be a covalent bond. Metals, covalent bonding.
So
No, it
ionic
wouldn't.
bonding.
Yeah, so you can directly, eliminate A and B because F is a metal and metals are all about being ionic,
Okay.
right? In chemical compounds, on their own there's metallic bonding, but that's not what they're asking, right? So obviously it's either C or D, right? So you've got oxygen, you've got sulfur. What kind of bonds do they make? Well, oxygen is not going to form an oxide unless you're talking about O2, right? So for example, sulfur dioxide or something. What kind of bonding do you have over there?
Covalent bond.
Yes.
Yeah.
Okay. Elements X and Y react to form a compound. Element X loses two electrons, so that's going to give, right. Make these notes when you're doing a paper. Okay, it's losing two electrons, it's going to have a +2 charge, and the element Y gains one electron, so it's going to be -1, and that's going to be times 2. Right, so there's going to be 2 of Y and 1 of X. So what is the charge on these ions and what is the chemical formula? So you've got +2, you've got minus, and they're going to be 2 of Y. So I'm going with this. What do you guys think?
Why did you multiply it by 2?
Why will you multiply by 2? Because X is losing 2 electrons. Each Y can
Uh,
only gain 1. So you'll need 2 of Y to take 1 electron each.
yeah.
Right?
So element 2 will be 2 plus charge.
Huh?
Element X,
Yeah.
uh, it will have 2 plus charge.
Yes.
And
You do the crossover method as well. Right?
uh,
And so you get,
element Y is -1.
yeah, and so you get X, Y.
Like in the formula, do we write the number of electrons?
No. This is the oxidation number.
Okay.
The +2 and the
B is the
-1.
correct answer.
Yes. Right, the +2 and the -1 I've written, that is the oxidation number. Obviously the oxidation number depends on how many electrons it's gaining or losing. Okay, which statement about graphite explains why it is used as an electrode?
What is meant by mobile electrons?
They're able to move about.
D.
D or B?
Okay, being a giant covalent structure is not helpful for being an electrode. Electrode means that it needs to be able to pass electricity,
So it is D.
right? It does not contain ions. It is not a metal. It is a giant covalent structure, but it is of no use to us. It does have mobile electrons because its structure is C3, right? So it does have free electrons, and so that is going to help it being an electrode because the free electrons will allow the passage of electricity. So it is D. All right. Methane, CH4 burns in air to form carbon dioxide and water. Balanced equation for the combustion of methane.
Yeah, Adam, go ahead. Actually, wait. Is it B?
It is B. Right, you've got one carbon and one carbon, you've got four hydrogens and 2 times 2 is 4. You've got four oxygens, two over here, two over here, so that is balanced and really. Now, since this is an MCQ, you'll only have one correct answer. Okay, question 9 is a bit lengthy. The equation for the thermal decomposition of sodium hydrogen carbonate is shown. So you've got sodium hydrogen carbonate and you're heating it to give you sodium carbonate and water and carbon dioxide. The MR of sodium hydrogen carbonate is 84. The MR of sodium carbonate is 106. In an experiment, 2.1 grams of hydrogen carbonate is heated, but not all of it decomposes. All of the carbon dioxide is collected and measured at room temperature and pressure. The total volume of carbon dioxide is 0.21, right? Okay. Uh, which statement is correct?
Hmm.
So we need to do a little math over here, right? First of all, the ratio between carbon dioxide and sodium hydrogen carbonate in the equation, what is the ratio?
Right.
It's 2:1.
2 is to 1, right? That means 2 moles to 1 mole. Right, now we need the moles. So you use 2.1 grams of sodium hydrogen carbonate. You do that, 2.1 divided by 84. And how many moles are you getting out of that?
2.1 divided by 84, you say, right?
Yeah,
0.025.
0.025. That is the number of moles of sodium hydrogen carbonate that were used. Right, which means how many moles of carbon dioxide would be produced?
1 mole?
No, how 1 mole? 1 is like the ratio in the equation. We're talking about actual experiment. So you divide that further by 2. Do you get
Okay.
do you get what I'm doing?
Yeah.
Right? And so you're getting 0.0125.
Yeah.
Right? Those are the
And
moles.
then you multiply that with 24?
Hmm?
You multiply that with 24?
Well, you'd end up with 0.3.
So is that
So
wrong?
yeah, so you multiply with that by 24, and so right, you get 0.3 decimeter cube. Right? Where in reality you had 0.21.
Yeah.
So that would give you 70%. 0.21 divided by 0.3 is 0.7. Now, does this help? the percentage yield of carbon dioxide is either 10 or 35. Right, so both of these are incorrect because the percentage yield is 70%.
Is it A?
Hmm?
A?
It is. How did you figure that out?
Guts.
Okay, guts is not a very good reason. Right, so we calculated the number of moles and the volume of carbon dioxide, but obviously that's not so. The only thing so next we need to focus on, right, sodium carbonate. And so the yield is 70%, right?
Okay. Yeah.
And so 2.1 grams is, right, 0.025, which is 0.125 moles also of sodium carbonate. And so 0.125 divided by, what should we call it? Sorry, multiplied by, not divided by, 106.
Okay.
0.0125. So, right, and I'm getting 1.325 grams of sodium carbonate that should be produced. Right?
Yeah.
Now this is theoretical. Theoretical why? Because if all of it would decompose, but they're saying not all of it decomposes. Right? So what I'm going to do is I'm going to take 70% of that, and 70% of that is 0.9275, which I can equate to 0.93, which is A. So slightly better reasoning than your gut. Now, does this calculation make sense?
Yeah.
Aaron?
Like I did it in like the other way, and that is easier for
Okay.
me to understand.
So how did you do it?
Like with the formula, I
How?
just divided both of them by 24, both the values.
Divide which value by 24?
Like
Which?
firstly we had the molar mass, then I divided 2.1 and 2.1 by 24.
24 or 84?
24
Why 24?
with the formula,
Which formula?
like the formula of concentration in which we used to divide by 24.
That is for gases.
But like it's already given at the end now that 1 mole is equals to 24.
Yes, but you don't know how many moles 2.1 grams is because the molar mass is 84. Did you end
Oh,
up with the same answer?
yeah,
0.93.
yeah.
That's interesting.
And the percentage yield is 70%.
Yes.
Because like I divided both the answers and multiplied them by 100.
Huh, if you could send me a picture of your working, I'd like to take a look at
Yeah,
it.
yeah.
Okay. Now we'll,
After the class.
yeah, after the class. Right now we're moving on. All right. So an electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed at the electrodes. Right? What is the electrolyte? The This is kind of like directly from the book.
C or D or C or B?
Not B, C.
Okay.
Right? You need dilute aqueous. Right? Aqueous being key. Right? Because
Like,
hydrogen, oxygen, basically that means that this is the electrolysis of water.
but like, why is it named sodium chloride? Because it is using like carbon electrodes and producing hydrogen and oxygen.
Okay, using carbon electrodes because they're inert, so they will not take part in the electrolysis process. And sodium chloride because it's going to give you the sodium and the chloride ions, which will help pass electricity. Because water on its own will not conduct electricity, and that's why you add either sodium chloride or you can use right what we learned dilute aqueous sulfuric acid. Okay.
Yes.
All right. Concentrated aqueous copper 2 sulfate is electrolyzed using copper electrode. Which ionic half equation describes the reaction taking place at the cathode? Right? The cathode is the negative terminal, right, where the positive ions go. And so they will gain electrons. So, which one is it?
Is it D?
It is D. Right? So it's not going to be B because that's a negative ion. It's not going to be C because this is losing electrons. Right? And that's not going to be A because you have concentrated aqueous copper 2 sulfate. Right? So water is not really a part. And secondly, looking at the reactivity, see if you remember the reactivity, see copper is below hydrogen, right? So hydrogen's up there, then you've got gold and silver, and then you've got copper down here, right? So in fact, sorry, you've got copper after hydrogen, then you've got gold and silver, right? And so copper is less reactive, and so the less reactive is always willing to gain electrons and go into its so elemental state, and so that's D.
Okay.
I hope you guys are following reasoning.
Yeah.
Okay, when powdered sodium carbonate and aqueous ethanoic acid are mixed, the temperature of the mixture falls. Right? Which statement is correct?
Is it an exothermic reaction?
The temperature is falling. You tell me.
B.
It would be a exothermic reaction.
It will be an exothermic. You're telling me it's an exothermic reaction.
It's B.
Yeah.
Okay, the temperature is falling. Exothermic means it's giving off energy,
Yeah.
which means the temperature will rise. There's heat, right? This is endothermic. The
Okay.
temperature falls. So that's endothermic. It's taking up energy.
Okay.
Right? So obviously it eliminates C and D. And then comes the point of delta H. So negative means giving out. Right? So that is for exothermic. So it's only B, as Sobia said. Right? A positive delta H is for endothermic reactions when heat is being taken in. Okay, magnesium powder reacts with an excess of dilute hydrochloric acid to produce hydrogen gas. Which statement about the reactions, about this reaction is correct? or are correct.
C.
Right, Haran?
Is it C?
It is C. Does this need any explanation?
Hadn't do you need that?
Well, since both of you got it right, I'm guessing no.
Yeah.
All right. The reaction between two aqueous compounds X and Y is slow and exothermic. The graph shows how the rate of this reaction changes with time. So the rate is falling with time. The student suggests that the rate of reaction decreases with time because the activation energy decreases, the speed of the molecules of X and Y decrease, the concentration of both X and Y decrease with time. Which one is it?
Is it A?
Hmm.
Soviet?
Uh. B.
Seriously?
Wait. Is it D?
Yes. What's your reasoning?
Uh. Because the reactants X and Y are consumed to form products.
Yes.
So the lower concentration means there will be fewer particles in given volume.
Yes.
So that will basically lead to fewer successful collisions
Good.
per unit of time.
Good. Right. That is sound reasoning. Now, as far as the activation energy is concerned, the activation energy is a property of the reaction.
Yeah.
Right. So that's not going to change. There is no reason for the speed of the molecules to decrease. In fact, if anything, it might increase. Right. So this is wrong as well. And so you're only left with three, which is option D.
Mhm.
All right. Hydrogen reacts with iodine to form hydrogen iodide. Which statement explains why the reaction is faster when the pressure is increased at constant temperature?
At constant temperature. Okay. 4. Wait. Wait. I'm thinking 1 and 4, but that's not an option here.
It's 1 and 3.
Okay. Does pressure affect kinetic energy?
No.
Then how are the molecules moving faster at higher temperature? Right? So it's not
Like
one.
pressure. um,
It says at higher pressure the molecules are moving faster. The speed of the molecules is kinetic energy. Pressure does not affect kinetic energy. So it can't be. At higher
2 and 4.
at higher pressure, more the molecules have the required activation energy. Again, activation energy depends on mostly heat or catalyst. Is increasing the pressure acting as a catalyst?
No.
No, right? And the activation energy, as I just mentioned in the last question, is a property of the reaction. So the pressure does not affect activation energy, and that's wrong. At higher pressure, you're squeezing them together, right? At constant temperature. So when the pressure is increased, the volume decreases, right?
Yeah.
Pressure and volume are. So when they're decreasing the volume, are they closer together? Yes, they are.
Yes.
When they're closer together, will they collide more frequently? Yes, they will.
Yes.
It's D. Okay.
Yeah.
Yeah.
Ammonium sulfate is used as a fertilizer. It is made from ammonia and sulfuric acid. Fill in the blanks. The dash is made by dash process in which dash is used as a catalyst.
B is the answer.
B,
B.
no, right? Ammonia is correct. Haber is correct.
Yeah.
Vanadium is wrong.
So iron.
Iron, and then you're saying ammonia with iron, but the process is not called contact process, so that's wrong,
Yeah.
right? And if you're going with D, then right, first of all, iron is not used with sulfuric acid, and neither is it called the Haber process. The Haber process for ammonia. So it's
Yeah.
sulfuric acid. The process is called the contact process, and the catalyst uses vanadium 5 oxide.
Okay.
Right? If you have sound knowledge, elimination is a very powerful technique. It doesn't always work, but it does work most of the time. Again, if you're sound with your information. Did you get that, Sobia?
Yeah.
Okay, the reversible reaction shown takes place in a closed system, and when they're saying closed system, that means we are talking about equilibrium at a constant temperature. When the reaction has reached equilibrium, so they're mentioning that more T is added. This guy, product. After the addition of T, which other substances increase in concentration?
C.
Yes, because you added more product. So, right, the equilibrium is disturbed, and so the reaction will move towards forming more reactants.
Yeah. Okay.
Right? Obviously, S is something different, and so T is not going to affect S, obviously. All right, in which equation is the underlined substance acting as a reducing agent, which
A.
means it is causing oxidation?
A.
That was quick.
It's A.
All right, so which one's acting as a reducing agent?
Helen.
Sorry, my bad. It's a reducing agent, so it is being oxidized, not causing
Yeah.
oxidation. My bad.
And mine is option A.
Yeah, yeah, both are okay. both of you said A, right? Now, which one is the reducing agent here?
Okay.
They already mentioned that, right? The underlying substance. So that carbon monoxide is going to carbon dioxide, so it's gaining oxygen. Okay. An aqueous solution
Can
reacts.
this be the last question?
Well, we'll may do 20, if not up to 22. So an aqueous solution reacts with a solid that produces, sorry, the products are an alkaline gas, salt and water, right? What are the aqueous solution and the solid?
B and C would be eliminated.
B and C would be eliminated. Why?
So A would be the answer.
Hmm?
A would be the answer.
A. It's question 19. A is not the answer.
I'm saying A would be the answer.
A, right?
Yes.
Yeah, no.
So B.
Well, you just eliminated B and C. Kobe?
Hmm? Yeah, I'm thinking.
I said that B and C would be eliminated.
Yeah, B and C are eliminated. Fine.
Yeah.
Right? But A is also not the answer.
So D would be the answer.
Well, obviously. Right?
Yeah.
If you put that as an equation, you've got NaOH and NH4Cl, ammonium chloride. And that's going to give you an alkaline gas, which is going to be NH3. It's going to give you NaCl, which is the salt, and it's going to give you water. Now it's
Okay.
obviously not balanced. Okay.
Yeah.
Right. So what I would have done initially is eliminate A and B because of magnesium carbonate. Right. Because if the gas is produced, it's going to produce CO2, and CO2 is actually acidic. Right. So the alkaline gas part is not satisfied. So with ammonium, I can get NH3. Now the question is, will it be sodium or will it be hydrochloric acid? So if you're using HCl and NH4Cl, right? We are not if we say we're getting NH3, right? We're not getting water because there's no water in this. We're not getting any water. There's no oxygen over here. So that eliminates C, right? And so we're going with D. Okay. All right, last question, I guess. Butanoic acid, so that's an organic acid, it partially dissociates, partially, right? Which means it is what acid? Guys, what kind of acid is this? If it says
Uh,
partially dissociates,
everything.
Acidic.
it is obviously acidic, it's an acid, it's an organic acid. But what does partially dissociate tell you?
That about the property or like the
Property. This is important to answering the question. No?
no
Is it gonna be E?
CH3 is pretty strong. No.
No, wait. So,
Right?
C.
For a weak acid, the closer it is to 7, the weaker it is.
so like,
Mhm.
it's either B or C.
C is alkaline, so it can't be C.
So it's
So
B.
it's B.
Right? Obviously, you also need to keep an eye on the color. Right? So thymophthalene is colorless in acid and blue in alkaline. Right? So, okay.
Okay.
Yeah, I guess we'll stop here then.
Yeah.
Okay.
Right. See you guys next time, inshallah. And you
Mhm.
do need a bit of revision in certain parts. So if you've noted where you were sort of stumbling, then
Yeah.
right, like this part over here, perhaps, right, the different processes and whatnot. Over here, definitely, right, operation energy and stuff. So revisit those topics.
Yeah.
Yeah.
Okay.
All right.
Yes.
See you next time, inshallah.
Allah Hafiz.
Allah Hafiz.
Allah.